Hello guys, welcome to a new video. Today I'm going to show you how to simulate dipole antenna in HFSS. Okay guys, these are the steps that we follow to do any simulation in HFSS. So first we have to draw the problem geometry, then we assign excitation, then we assign the problem boundaries, and finally we do some setup in the simulations, and that's it. Okay, so let's start with the first step, which is drawing the problem geometry. So to make this step easy, I first define the problem geometry parameters or variables. So the first parameter is, let's say, the radius of antenna. Let's say our antenna. And let's say the radius here is 0.5 millimeters. And then the length of the antenna. Let's say the total length is 30 millimeters. And finally, the gap. Let's say it's like 1 millimeters. Now I have all the variables are ready to be used. Okay, so now let's draw the first arm of the antenna. And I just drew like arbitrary cylinders, then I gonna precisely put the dimensions here. So start from x0, y0, but for the C, start from gap underscore antenna over 2. And for the radius, it's just like the radius of the antenna, and for the height is the length of the antenna divided by 2 because they are symmetrical arms. Okay, now we have the first arm here is ready. And as you see, the default here is that the assignment of the material is vacuum. That's why we're going to change it. We are going to change it to copper. Okay, and then we are going to mirror it on the Y in the Z axis to have the second arm. We mirror this arm from here, mirror plus duplicate, and I mirror it in the negative Z direction. And just to make sure, I'm going to enter here 0, 0, minus 1, minus 1. Okay, so now I have the second arm here, and my antenna is ready. We are done with the first step. Let's go to the second step, which is assigning the excitation to the problem. So to assign excitation, I'm going to use lumped port, and to assign lumped port, I need to define a rectangular sheet to use it. Okay, so from rectangle here, I just plot any rectangle, then I'm going to precisely choose it. Okay, so let's say it's in X direction, and the position here is 0, negative R, and let's say the Z is 0. Okay, the Z is negative GG over 2. Over 2. Okay, so from rectangle here, I drew a rectangle in between the gap here, something like that. Then I'm going to edit it to be precisely what I want first. And this is how it looked like at the end of the day. Now we are ready to assign the lumped port. So we choose the rectangle here that we already drew, and from here assign excitation lumped port, and we choose the input impedance to be 50 ohms. And next, then we define here the integral line and choose it something that is going from the lower arm to the upper arm, and that's it. So we are done with the second step. Let's move to the third step, which is assigning problem boundary. And this is the easiest part here. It's just from right click here, we choose create open region, and we choose the operating frequency to be 5 gigahertz. which is something relevant to the length of the dipole antenna, and here we choose a default here as radiation boundary. Okay, so let's move to the last step here, which is set up the simulation. So from here we go to simulation and setup here, and we choose like to be like broadband simulation, which allow like sweeping of frequency, and let's say from 1 gigahertz to 10 gigahertz. Okay, and that's it. Like it only remains to make a simulation. So from here, HFSS analyze all. So now our results are ready. So to display the results, we go from here, right click and create rectangular plot, and we plot S11 here, new plot. And as we see here, the antenna is matched around around like 4.15 gigahertz, which is something close to the theoretical operating frequency of the antenna based on the dimension, which should be lambda over 2. So to see the radiation pattern, we go to results here, and here far field plot and 3D polar plot, and make like, let's draw the gain total. And this is the gain of the antenna, and it looks like the donut shape, like ideal plot, where the maximum gain here is something around 1.8. Thank you guys for watching the video, and see you in next videos.